This is page 165 from lesson 8.5 in your textbooks. Guided practice problem number 2. They're asking us to find the surface area of this birdhouse. And again, surface area is all the exterior exposed region. So you need to come up with a plan, find out how many sides are exposed, what shape are they, find the area of all the sides you're talking about, and then add them all together. So that's the first thing that we need to do, is devise our plan. We look at the top, and the top is this pyramid right here. Okay, and it has how many sides that are exposed? 4 sides. It's got 4 exposed sides. So we are not going to find the area of the bottom of the pyramid. We're only going to find those 4 triangles. The next question would be, are all the triangles the same, or are all the triangles different? Well, this is a cube, they're telling us. So it's a cube with a square pyramid on top. Square means that the bottom, okay, is a square, which means all 4 of those sides are equal to each other. So in the pyramid, the triangles will all have a height of 13 and a base of 10. So we need to find 4 triangles. We need to find the area of 4 triangles for the top part. For the bottom, the cube, the top is not exposed. So a cube has 6 sides, and if it's a cube, that means all 6 sides are going to have the same area. They're all, as you see here, 10 by 10. So this side here in the front is 10 by 10. The back, the sides, and the bottom are all 10 by 10. So they're all squares. And again, the top is not exposed, so we're not finding the area of the top. So we only need 5 squares. We need the area of 5 squares. And then it's got this hole cut in there for the birds to get into. So that takes away from the surface area of that side. So what we would need to do is find the area of 1 circle. And we are going to subtract the area of that circle from the area of that side of the square there. Okay, once we add all of this together, so add these, and then you're subtracting the circle. Okay, so again, we developed our plan. Now we need to write the formulas for that plan. So the triangles, the formula to find the area of a triangle is 1/2 times the base times the height. And base and height are the 2 sides that form a right angle. So area equals 1/2 times the base is 10 and the height is 13. Flip back, and base is 10 for each of the triangles. That measurement's 10, that measurement's 10. All of their heights are 13. The 10 by 13 are the 2 sides that are making the right angle. So that's what we've got for the triangles. And we said that there are 4 of them. So after we find the area of those, we'll get 65. And then we multiply that times 4, because there are 4 congruent triangles. Multiply that by 4 and you'll get 260. So the area of the 4 triangles at the top are 260. Then we have 5 squares. And to find the area of a square, its area equals side times side, because the squares, the sides are the same. You can say length times width, that's fine too. So area equals, and those squares are 10 by 10. So the area equals 100. And that's for 1 side. And we said that we've got 5 exposed sides. Again, the top of the cube is not exposed, so we only have 5 exposed sides. So we'll take the 100, and we will multiply that times 5, and we'll get 500. So that's the area of the 5 squares. Now we need to find the area of the circle. And the area of a circle is area equals pi r squared. So area equals 3.14 times the radius. If we go back, you'll see the radius of the circle. It tells us that all the way across is 4, and the radius is only halfway across. So halfway across, of course, would be 2. So our radius is 2. So 3.14 times 2 squared. And when we get the answer for the circle, we get area equals 12.56. Now we take all three of those numbers. And so again, we want to add the 4 triangles, 260 plus the area of the 5 squares plus 500, and we want to take away the area of the circle, 12.56. And we type all of that into our calculator, and we will get 747.44 inches squared. And again, this one is surface area. And if we go back, they're not asking us to round to any specific place value, so we can leave it just like that. Now, if you round to the nearest tenth, that would be fine. 747.4 inches squared would be fine as well. But there's your answer. Okay, next question. 8.3. Okay, now on this one, finding volume, we're dealing with volume here. Find the volume of the solid. So see what you've got. You have a cylinder right here, and then they're saying that you have an opening in the cylinder that's in the shape of a cone. So all of this region in there is all open. So if we're dealing with volume, we're talking about the inside of that cylinder, and we have an opening in the shape of a cone. So we have to come up with a strategy. How are we going to solve this problem? Well, the strategy would be to find the volume of the cylinder and subtract the volume of the cone. That's it. Find the volume of the cylinder, find the volume of the cone, and then you're subtracting that volume of the cone from the volume of the cylinder. Flip over to our writing over here. All right, and again, first step, write your formulas down. So the cylinder, the formula for the cylinder is volume equals pi times the radius squared times the height. For a cone, our formula is volume equals 1/3 times pi times the radius squared times the height. Now we plug in everything that we know. For the cylinder, volume equals 3.14 times, we flip back to our drawing, the radius of the cylinder. It tells us that it's 22 centimeters all the way across, so that means that it's only 11 centimeters halfway across. So our radius is 11. And the height of the cylinder, you'll notice right here, says that the height of the cylinder is 15, and it mentions it in here. The height is 15. So we have a radius of 11 and a height of 15. So our radius is 11, so 11 squared times our height, which is 15. When you do all of that math, you'll get 5,699.1. So that's the volume of our cylinder. We've got that number. Now we need the volume of our cone. Volume equals 1/3 times 3.14. Now let's flip back and see what the radius and the height of the cone are. So if we look at the cone, it has a radius of 7, it tells us, and a height of 10. And again, it even says in the wording over there, a radius of 7 and a height of 10. We go back and plug those figures in. Radius is 7, so 7 squared times the height, which is 10. When you multiply all of those together, you'll get 512.9. And then again, so we got our volume of the cylinder, volume of the cone, and we said our strategy would be to subtract the cone from the cylinder. So 5,699.1 minus 512.9. When we do that subtraction, we get 5,186.2. And when we read these directions, they ask us to round this one to the nearest whole number, the nearest units spot. Again, whole number is the 6. So we look at the tenths, which is a 2, and the 2 is not big enough to change the 6. So our answer would be 5,186, and it's volume, so centimeters cubed. 5,186 centimeters cubed. Okay? So again, your strategy has got to be find out what exactly you need to do, establish what formulas you need, write the formulas down, plug in all your information, follow your strategy, and solve for the answer.